In this quick video, we're going to go over inverse functions. So an inverse function basically reverses the original function, and we're going to understand exactly how to find the inverse. So first of all, let's give us a quick review of what a function is. So a function is a rule basically that takes normally something like x to y. So in this instance, we have got 3 lots of x plus 2 is f of x. Now, in terms of a graph, this is like plotting y equals 3x plus 2, has a gradient of 3 and an intercept of 2. And we can find out what different points, what corresponding values of y we have. So when x is 1, we have a value of y is going to be 5 because we just substitute x as 1. So what is an inverse function? As discussed, it reverses the process. So normally when we're talking about inverse functions, we write it as f to the power of minus 1, and it just undoes the process. So let's go over it. So these are the steps. I'd recommend you pause the video and write these down. So if we're writing the function y equals f of x, first step is to switch around x and y. So rather than writing a y, we're going to write an x. Rather than writing an x, we're going to write a y. And then we solve or rearrange the equation for y. So we make y the subject of the formula. So at the moment, we think that y has been times by 3 plus 2. So we reverse that process. So the opposite of plus 2 is minus 2 from both sides. So if you minus 2 from the left-hand side, it becomes x minus 2. And if you minus 2 from the right-hand side, it obviously just becomes 3y. And then obviously to reverse the times 3, we just divide both sides by 3. So this is considered the inverse function. So if we have this function, we could put it onto Desmos. And then if we have the inverse function, it's going to be y is equal to x minus 2 divided by 3. Now, what is special about this? Now, if you get the line y equals x, which is the green line, inverse functions are going to be symmetrical either side of this line y equals x. And this is also really special because if we get a point like you can think of them as opposite operations from each other, because if you pick a point 5, 1 here, and then we reverse the points around 1, 5, we can see that both 5, 1 and 1, 5 have a same corresponding distance from the y equals x line. So to get a point from the function such as 1, 5 onto the inverse function, you just swap the coordinates around. So 1, 5 becomes 5, 1. So in order to check our work is correct, we can see this is true by using the 1, 5 example, because if you substitute 1 into the original function, you get 5 out as the y. Let's see that here. When you substitute 1 here, 3 times 1 plus 2 is going to be 5. Whereas if you switch those coordinates around and substitute in 5, 5 minus 2, which is 3, divided by 3 is 1. So it works. We know this function is correct if the coordinates that you've generated from the first function can substitute nicely into the second formula. Let's go over some practice questions. If we have the function x plus 7, the first thing you do is you swap the variables around. Then you rearrange it to make y the subject. So we just have to minus 7 from both sides. Nice and easy. This one's a little bit more complicated. First of all, we swap the x's and y's around. So we have x equals 4y minus 5. And then to solve this, we first of all plus 5 to get rid of the minus 5, and then we divide by 4. So this is our answer. Last but not least, to find the inverse function of this, we swap the variables around, and then obviously we're going to minus the 3. And then to get rid of the half y, we need to do times by 2. So we are going to, first of all, minus 3 from both sides, and then because we're timesing everything by 2, this becomes 2x, and this becomes minus 6. A common error would be for people to leave this as minus 3. So that's it, and you can pause the video to read the summary.